Hello, guys. Good evening to one and all. I hope everyone is doing good today. And now, for today, we are going to cover up our lessons on data engineering interview series. And if you have been following us regularly, this is the 16th video of our data engineering series. And here is a disclaimer I would like to address to you. Uh, this video is standalone video, so you don't have to worry about covering up of our previous videos. But however, if you ask me personally, if you are preparing for your data engineering interview, you feel free to go back to our previous video and have a quick look on those. And before we jump to the video, I would like to welcome you all, and I would like to introduce about our company. We are Data Valley, the fastest growing edtech company of 2025. And what do we offer? We offer you with IT solutions, trainings, and then placement support. So, what do I mean by IT solutions? Let's say you have a company and you need a talent pool of people who can take over the job from day one. Yes, we do have a talent pool of people who can take your business requirement from day one. And then talking about the trainings, yes, we do have a training institute of our own where you can get trained on multiple subjects. And talking about the trainings, it's not like just theoretical learning, but it's more of hands-on practice, which is going to get you to a job. And our goal is not to get you job ready, but to get you project ready. So irrelevant of what company or what job you're looking for, you must be able to take down the projects from day one. So that is our ultimate goal. So our trainings are very intense. You can check out more about these information in our website at datavalley.ai, where you will find all the information about what are the training modules that we have, what is the mode of training, and what is the duration of each training subjects. So you can have a rough look on that. Just to give you a broad context, we have trainings in data science, data analytics, data engineering, ethical hacking, cybersecurity, SQL, Python, Java, Selenium, Stack, web development, UI UX designing. So there is plenty of subjects in place for you to get trained on. So whatever is in demand, whatever is hot in the industry, you can be very sure that that is in our institute for you to be getting trained on. And then we have our 100% placement assistance as well. So we assure you from our end that once you enroll to our institute, you'll be getting 100% placement assistance, and all the support will be provided even after your job. So even if let's say you have joined the job and you need a support, yes, we do provide you job support even after you have been hired from a company. So we play a crucial role to make sure that you are well gone in your career. So we will help you with that, and we are here to get you higher and higher in your career. And today, what are we covering? Data engineering series. And before we jump to the video, myself, Franklin, I've almost got 3+ years of experience as a data engineer, and I'm super glad to get this video to you all. And you all know the routine. What you have to do: grab a cup of coffee, and if you have the habit of taking notes, please feel free to take your notepad and have all your stationaries ready, so that you don't miss out on any of the key points that is being mentioned in this video. Okay, today is our 16th video, and if you all remember what we have been discussing, so we have been talking about AWS Glue, if you all remember, isn't it? So you might be wondering, no, this is the sixth video of this particular series. Yes, this is the sixth video of our AWS Glue, but the reason is very simple. You need those number of modules to get you prepared. We need those number of modules to get you, have your information at your fingertip. So, and in today's video, we are talking about the AWS Glue, and in context, we are talking about the performance. So this is the second video of the performance. All right, and this is our agenda for today. So these three questions are the crucial thing that we'll be discussing in today's video. So the first question: how to balance cost and performance factors to achieve optimal results. Okay, one key thing you must know here is that There are cost factors and then there are performance factors. But the key thing is in how are you going to balance between both cost and your performance. So your goal is to get the best performance, and the two things that you need to balance between is cost and performance. If you're wondering, are these the only two factors that we need to consider for our job or business? No, there are other things like security, high availability, fault tolerance. How do you backup and recover your data in case if there is a data loss? Uh, how to achieve stability. So there are a huge number of factors that you need to consider as well. But just keeping the context about the achieving optimal result based on cost and performance factor, now we will learn how to balance between these two. So you can see here a graph, right? So the graph goes like cost down and performance up. So let's say you have your company. Let's say you have your own company. What would be your intention? Your main intention as you have a business is to save amount, right? You need to save the cost. But at the same time, though you're getting the profit or though you're saving the money, you would also emphasize on reducing the cost being spent. So you cut down on the expenditure and at the same time you want to save on your cost as well. And it's it's always the business goal. But however, when talking about, I know this is the expectation in place. But if you're wondering if we can always achieve whatever the expectations are, I wouldn't say no, but at the same time, I wouldn't say it's 100% yes. Because in reality, if you need performance at times, you need to spend money. It's going to cost you, but you will be getting the increased performance as well. So there are different scenarios where this would work. Okay, it's not always that more money, more money you put, the better performance that you get. But there are other key things that you need to consider as well. So sometimes you might be over provisioning, but what is the point if you're not using all the ability of your resources? So in that, you're not achieving an optimal result, right? You're over provisioning and you're wasting your money. So now we will see all the list of things that you need to keep in mind to balance your cost and performance to achieve your optimal result. First, right size resources. So first thing to balance your cost and performance is by having the right amount of resources. So if you ask me personally, I would always suggest you start with smaller worker type or depending on your job or depending on the data to be processed. And then you can fix a reasonable number of DPUs and then you must monitor your performance. So always start small. Let's consider an analogy, okay? Let's say you want to start a restaurant. Would you rather prefer to have a small setup, like maybe let's say you have like three tables, and then you have like six people, including the servers, the cooks, the cashier, and everyone. You have a smaller setup, and based on your product, now people are going to come to your restaurant. And the more people they come, now you're planning to extend. So now you can either floor up or either you can extend the space. So this is less riskier and it is saving all your cost as well. But in other scenario, let's say you're starting a restaurant. Let's say it's like very huge and it is having like 50 tables, and there are like 25 people who are working under you. So everything is fancier, everything is good, everything looks perfect on paper. But what if you have poor customers? You're not getting customers. What if your customers don't like your food? What if the customer doesn't like the way you prepare, the taste you make? So in that you're losing your cost, right? And on top you're playing you have to pay for your employees as well. So you're wasting money on that, right? So similarly, talking in context to our data engineering and especially AWS Glue, always remember that you must have the right amount of resources. You should not over provision it. Okay, whatever is required. Whatever you think is reasonable to start with, go for it. And if you are wondering what is DPUs, DPU is nothing but data processing unit, okay, which is nothing but a combination of all your compute, your network, your input output operation, the storage. So this is like a combinational term for all these kind of usages, and you call it as DPUs, okay, especially in Glue. So how much resources have you spent for data processing? And also it is very much important that you monitor the performance for the resources that you are provisioned, okay. So key thing is start with smaller worker type, or in other words start with the right amount of resources and keep monitoring the performance as well. And depending on your performance, if you require more, then provision the extra resources. And then you have got optimize your ETL script. So refactor your script to reduce shuffles and parallelize tasks effectively and minimize the data scans. So what I'm trying to tell here, let's say you have your glue job script, okay? So you are having a ETL to be performed, and now you have your glue script ready, okay? So what you can do is you can try to optimize your ETL script. And in what ways can you optimize your ETL script? There are certain things that you need to consider so that your cost is cut down, and at the same time you're not compromising on your performance as well. The first thing I would like to address is reducing shuffles, okay. So what do I mean by reducing shuffles? So when you try to perform a job in your Glue, you all know that under the hood you have Spark engine, right? So AWS Glue, but under the hood you have Spark engine, which is doing the native, which is doing the data processing role. So what is the Spark architecture include? It includes a driver and then a few executors depending on what you have provided, right? Okay, fine. So now when you're trying to process the data, all these data gets put down into multiple executors, okay. So when you put your data into multiple executors and when a job needs to be performed, or when an action is called, or let's say any of the white transformations, maybe a group by, maybe another aggregate function like sum, count, etc. So in that case, you are going to create a lot of shuffle between these executors, right? Because the data has to be moved between all of the executors, and therefore what is going to happen is that you are going to increase the shuffles, and because it involves a lot of input and output operations and lot of data movement, it is going to endure your cost and your performance as well. So more the shuffle that you have, you're going to have poor performance but higher cost. So always try to reduce the number of shuffles. How can you do it? You can like partition your data and then load it up. Therefore, particular executor is going to have only the one kind of, or one cardinality of data. Therefore, the shuffles are limited. Or you can try to use narrow transformations rather than wide transformations. And then you can try to parallelize your tasks effectively. What do I mean by parallelize your task effectively? So as I said earlier, you're going to have Spark architecture under the hood of Glue. So when you're using AWS Glue, you must make sure that all your data processing is parallelized between the executors. So let's say you have 10 executors in place, and what if you're just processing all your data within 5 executors? So the extra 5 executors are just going to remain idle, and you have over provisioned it, and you're not using to the maximum capacity of your Glue job. So what you can do is, depending on the number of jobs, or depending on the data, depending on the right amount of files that you have, you can try to split all these data to multiple executors. You can parallelize them, and more you parallelize, you will be getting better performance as well. So always try to parallelize your task in an effective fashion. And then you can try to minimize the data scans. What do I mean by minimizing the data scans? So let's say you have 1 GB of file, and if you're storing the data with partition, let's say my data is there and I have a region column, and I'm partitioning it based on the region, and and the region has four types. Let's put as north, south, east, and west. So my 1 GB data would be roughly splitted equally into four, like approximately 250 MB for each of the partition. So let's say I'm running a query and I'm saying that, okay, I want to fetch a data for this particular partition. And now instead of scanning and executing all my data processing for a 1 GB file, I'm just processing the data for the 1 by 4th of my data. Therefore, I'm not performing full table scan. I'm saving up the performance by at least 75%. So this is a major step that you can have to optimize your ETL script. Next, choose efficient data formats. Convert your data to columnar formats like Parquet, apply partitioning, and use appropriate compression for better read and write speeds. So what do I mean by columnar formats? So your usual formats like CSV, TSV, JSON. So these are row based. Okay. So all your data will be stored in a row fashion. For example, let's say I have three columns, serial number. Okay. So serial number one, customer name Franklin, and let's say oh, let's put it in another easy way. Let's say you have a product catalog. Serial number one, the first product is laptop, and then the price is 60,000. Second product is serial number two, where the product is mobile phone, and the price is 6,000. And then you have one more product, TV, that is priced as 40,000. So you have three columns, right? And three columns and three rows. So what happens in your row data is that your first row, second row, third row, they all get placed next to each other. But in columnar data, what happens is that first all your serial number gets stored in one place. So one, two, three, then your product, which is laptop, TV, mobile, and then the price, 60,000, 6,000, and 40,000. So when you're using a columnar format, and when you are choosing the particular column to be scanned, so instead of going through all your data, you can specifically choose the right column and then you can scan the data efficiently. Okay, and the columnar format is provided by either Parquet or ORC. You can use an ORC as well, which is nothing but an optimized row columnar. Okay, so when you use these kind of efficient data formats like Parquet or ORC, or what you can do is, and you also can use compression on top of this. So when you are trying to write your data in a columnar format, you are trying to save your cost in your storage space. You are trying to save your you know the data getting being read. So you're saving in your input and output operation, and also you're going to have an efficient performance as well. All right. So this is one better strategy you have in place. And then on top of this format, you can also apply compression, which is going to save you further the cost and your performance. So the effective compressions are like Snappy, gzip. So these are the efficient compressions that you have in place. And then also you can use partitioning as well, which is going to improve the performance and at the same time reducing the cost as well. Fourth thing, enable auto scaling and bookmarks. Leverage auto scaling to dynamically adjust resources and use job bookmarks for incremental data processing to save on processing time. So when you try to use auto scaling, what you are doing is you can dynamically adjust your resources. Okay, so how are you going to dynamically adjust the resource? So what happens is that while setting up the auto scaling, you have two things. So you will be setting the maximum and the minimum number of resources, and based on the requirement, whenever you need to scan the data, depending on that, okay, so you will be using the right amount of resources. Okay, so that is one of the key thing that you can have in your uh, application. Okay, and what happens with the dynamic resources is that, let's say you have 1 GB file you're getting processed, and you have like let's say 2 to 10, the 2 is the minimum and the 10 is the maximum number of resources that you have set. So let's say you have 1 GB file and all you need is 2 GB, I mean two, let's say two executors. So when you're just using that, you are saving your performance, right? So instead of over provisioning, you just want two executors and you're doing it. And now let's say you have like 10 GB file, and now you're processing, and now you need to now you need to increase the number of resources. So now what you can do is you can automatically change that to 10 executors. Therefore you're not over provisioning first, and secondly you're just using the right amount of resources when you need it without overpaying. And then use job bookmarks for incremental data processing. So what is incremental data processing? So let's say I have 5 files today. Okay, and when you're trying to uh, okay, so when you are trying to process your data, let's say our files from 1 to 5, so 1 2 3 4 5, and now you have processed it. Now you have finished processing it, and next, now you're getting new set of files. The new set of files are 6 7 8 9 and 10, and now I need to process it. So if I scan from 1 to 5 or process my data from 1 to 5, and then if I'm also processing the files from 6 7 8 9 and 10, so this becomes an inefficient strategy, isn't it? Because I need to scan only the right amount of resources, not all the files that are present. So to handle these kind of scenarios, so whenever the new files comes into play, whenever new files are getting dropped in your S3, so what you can do is you can have an incremental data processing setup, which is just going to process the data whatever is new. Okay, so to process your incremental data, you have something called as job bookmarks in your glue. So when you have job bookmark enabled, which is nothing but, let's say, when you read a book, we have the habit of keeping a bookmark, right? So what does it mean? It means that I have finished reading the data, I mean I've finished reading the pages, and I must start from this page. Similarly, for your data, what you do is you set up job bookmarks, and instead of reading all the data from the beginning, you just leave out whatever has been already processed, and then you read or process the data from where it needs to be processed. All right. Next, setting appropriate timeouts. So what is a timeout? Let's say you're writing an exam, okay, and they usually give you time slots like 3 hours, right? 2 hours, 3 hours, whatever you have. So what happens once you finish writing your exam, or once you have crossed the 3 hours, then you cannot write your exam, right? So when you finish it, they'll get the paper from you, right? So when you set similar timeouts for your job, you're going to prevent from them running indefinitely. So when you run a job, you need to start somewhere and you need to end it somewhere. You don't want it to be running, indefinitely, right? So what you can do is you can set proper timeouts so that once when your job time has reached particularly, your job will stop automatically. Okay, for example, let's say you are setting up a timeout like 20 minutes. So what happens after 20 minutes? Your job must end. That is the right approach, isn't it? So whenever your job, even if it has completed or even if it hasn't completed, your job will stop. Okay, therefore you're saving up your indefinite running. And then by definition, define timeout thresholds to prevent jobs from running indefinitely, controlling cost for time critical or less critical workloads. Use flex jobs for non time critical workloads. The flex job type is designed for workloads that don't require immediate execution, offering a cost effective alternative for less time sensitive tasks. So, what you do is you have an option called as flex job. So, whenever you have a workload that doesn't require any immediate attention or that doesn't need any immediate execution in place, so what you can do is you can have your flex job in place, which is going to help you in a way that you're not going to pay you're not going to overburden, right? So you can avoid your overburden, right? So whenever there is extra resources, but by that time these flex jobs can take over the job and it can execute it. So this is very crucial for non time critical workloads. And then you have monitor and track costs. Regularly use tools like AWS Cost Explorer to monitor your glue job expenses and identify areas for optimization. So, what you're doing is, yes, you're spending money. So, how do you want to save the cost then? So, if you only have a track of what you're doing, only if you are sure that how you are spending your cost, only then you can understand where your cost is going and how you can save it. So, what you have to do is try to monitor your cost, where the resources are being used, what is the cost for each of the resources, what is the amount being put separately for each of the services that you're using. So for these kind of setup, set them up independently and you can try to understand where the cost is flowing up. So by tracking all your expenses using AWS Cost Explorer, you can try to bring a balance between the expense and uh, the performance that you are expecting for. So this is how you balance your cost and your performance. And then of next, I have to talk about how to optimize the performance of a glue job, especially with larger data sets. So should we really optimize our glue job? Is it necessary? Do you think it's necessary? Feel free to put your answers in the comment section. Yep, thank you. Yes, that is necessary. You always need to optimize the performance of your glue job, and especially when talking about the larger data sets, yes, it is very much important. Okay, now let's see how to optimize the performance. Optimizing AWS glue job performance, especially with larger data sets, involve several key strategies. The first part is going to be about data partitioning and pruning. What is data partitioning and what is data pruning? Data partitioning is nothing but where you try to store all your data with a particular, uh, you know, with your data getting partitioned. Okay, so instead of just storing your data without any partition. This is a very efficient strategy in place. So we already learnt about partitioning, right, in our previous question as well. Store data in Amazon S3 partitioned by relevant keys like example date and region. This allows Glue to read only the necessary partitions, significantly reducing the amount of data scanned. For example, in your data engineering place, what I'm trying to tell is in your data engineering project, you might be getting a lot of data, right? And each day you will be getting new data coming up. And for sure that each of your data is going to have its own date, right? So for example, today is 16th. So I'll be having the data from 16th. And for tomorrow, I'll be having the data for tomorrow. And this goes on, right? So what you can do is you can have your partition based on your date. So when the data comes and gets dumped into the S3, each day is going to have only the data for that particular day. And when you're trying to scan your data, and when you set this particular filter, now you will be able to scan only the data that is necessary for a particular date rather than looking to scan all your data for all the dates and whatever the year region what you have. Okay. Or next you have use push down predicate. So one key thing about using push down predicate is that, so when working with AWS Glue dynamic frames, leverage push down predicate and catalog partition predicate to filter data at the source, minimizing input output operation and processing. So when you already partition your data, now it becomes very easier in a way that because you already have your partition in place, first of all, you're not scanning all your data. And when you try to filter, what happens is that only the necessary data will be scanned, or only the executor where the particular data is there, only that data will be scanned through, instead of just scanning through. When you use filter, you're just filtering it, right? So for example, let's say you have 100 records, 50 is of boys and 50 is of girls. And now I'm saying try to find the guy Frank. And now you have partition in place, which is gender. And based on partition, I have split my data into two parts. One is for male and the other one is for female. So because Franklin being a male, instead of going through my 100 records, you can just go through your 50 records under the boys partition. Therefore, you are going to have, uh, you know, data partitioning as well. You'll be having predicate push down in place. Resource allocation and scanning. Choosing the right worker type and count. Select worker types. Example like standard G.1x, G.2x, and adjust the number of workers based on the job's complexity and memory requirements. More powerful workers or a higher count can reduce execution time for complex transformations. It is very crucial to have the right amount of resources in place. Why is that? Because when you have more data, okay, and when you have larger resources in place, or let's say you are having the best executors in place, but what if for a lower data you have all these kind of over provisions in place? So this is an inefficient practice, right? So always try to have the proper worker type and try to have the right number of workers depending on the job's complexity and memory requirement. More powerful workers or a higher count can reduce execution time for complex transformations when you have a lot of jobs to do. Okay, what you can do is you can try to reduce the execution time by having best resources that is necessary for your job. Optimize parallelism. Ensure tasks are evenly distributed among executors. Use repartition or qualys to manage the number and size of output files, preventing data skew and bottlenecks. So qualys and repartition are strategies which helps you to reduce the number of executors. And one key difference between repartition and qualys is that with repartition you can either increase or decrease your number of executor, but with qualys you can only reduce the number of partition. Okay, so that is the difference. And there is also major huge difference between repartition and qualys. While you use repartition, there is going to be a lot of data shuffling, but with your Qualys operation, there is not going to be any data shuffling. So whatever the data was in the executor that is to be eliminated, that particular data just gets put down into under other executor, right? So no data shuffling, just the data gets pushed from one executor to the other one. So more you try to distribute your data to different executors, you'll be able to achieve parallelism. Code and script optimization. Use the latest AWS Glue version. We always want to use the latest version of a product, right? Either it be a software, either it be a mobile phone, either it can be, whatever the latest technology that is in place, whatever the books even we use, we always go for the latest versions, right? Why is that? Because the latest version is going to have the latest features. It is going to have improved performance. It is going to have better security. It is going to have all the bugs getting fixed unless there are new ones in the new version. So all these pre-existing problems will be handled in a better way. So you have all these kind of strategies in place, right? So always go for the latest glue version so that you can benefit from performance improvements and new features in the latest versions. And then you what you can do is you can have efficient data formats. So utilizing efficient data storage formats like Parquet or ORC for better compression and faster read and write operations. So whenever you want to have your better code and script, what you can try to do is have first in place an efficient data format. So one efficient data format, okay. First of all, always go for a columnar type, and within the columnar you have Parquet and ORC. And personally, I would recommend Parquet because that is now widely used because of its better performance and better compression as well. So when you try to compress your format and have a format that is better, you get improved input and output operation. At the same time, you are reducing the cost as well. Optimize Spark transformation. Employ PySpark's filter to push down predicates and repartition for data distribution. So when you try to use filter function, what happens? So you are trying to, you're trying to do a predicate push down and select the data only that is necessary. Therefore, you're not doing full table scan. And when you don't do full table scan, you're obviously saving the cost and you're improving the performance as well. So always try to use filter function and then repartition to distribute the data between the executors. And then you can try to use optimize UDFs. So when using UDFs, always go for the native ones. Okay, so whatever UDFs are in place by a particular engine, for example, Glue or Spark. Okay, you have your UDFs. So instead of just uh, using one that is created by you, when you use the native ones, you will be having improved performance and you'll be avoiding any kind of bottlenecks as well. And then job bookmarking. Enable job bookmarking for incremental processing, preventing reprocessing of already processed data. So we just spoke about it, isn't it? So when you enable job bookmark, instead of processing the data that has been already processed, you just process only the incremental data. So only the new data that flows in, only the new data that comes into your uh, S3 or whatever the storage that you have, the database or warehouse. So you're just processing it, right? You're processing only that is new, not every file that is in a particular folder. Okay, so you want to do incremental data processing, which is going to save your cost, and you enable your incremental processing by enabling job bookmarks. And then you have memory management. Allocate sufficient memory. Ensure the glue job has adequate memory allocated to avoid out of memory errors, especially with larger data sets. So when you have your glue job, okay, just have the right amount of memory. And why is that? Because when you are trying to process a larger data sets, and if when you don't have proper memory in place, you are going to throw out with the out of memory issues, which might cause you a failure of a job. Okay, so always ensure that you have an, optimized, or you have adequate memory, okay, for your glue job, so that you don't end up with the errors or failures of this type. Consider memory optimized Spark. Utilize features like memory optimized Spark to manage memory more efficiently. So first thing is you need right amount of memory, and then while using the memory Spark memory engine, what you can do is you can try to have an optimized Spark in place. Okay, therefore you'll be able to manage your memory in a more efficient way. Monitoring and tuning. Monitor CloudWatch metrics. Regularly monitor CloudWatch metrics for worker utilization, job duration, and error logs to identify performance bottlenecks. So, what is the use of CloudWatch? So, as the name suggests, it's easy to understand, right? You're watching. So, you're watching out on the metrics, you're watching out on the resources, you're watching out on the cost. So, you always need to have CloudWatch in place because you will be having the logs as well for the particular resources. Okay. So, if you are trying to watch or monitor your metrics, for example, the amount of resources that was used, what is the duration of a job, if there are any error logs, so you can try to rectify if there are any errors, and then you can try to optimize your performance without any bottlenecks. Analyze Spark UI. For streaming jobs, use the Spark UI to monitor structured streaming trends and individual micro batch processing details. So, for example, you might be having a streaming job to be performed. Okay, so it's like a real-time pipeline, and you want to, uh, you know, monitor it, and you must know what's happening with the performance. So, at that time, you can use the Spark user interface to monitor all the trend of your streaming data, and then also you can monitor the individual micro batch processing as well. Okay, so by taking note on these kind of metrics and details, you'll be able to save your performance. Data pre-processing. Consolidate smaller files. So when you're using S3, the chances are that you're going to get large amount of data, and sometimes the worst thing is that each file will be like 1 MB file, 2 MB file, 3 MB file. And each time what happens is that when you're trying to process your data, you're going to give a lot of S3 requests. Okay, so when you're giving a lot of S3 requests, you're trying to access the data, and then you're going to decrease your performance. So to get the performance gain, okay, what you can do is you can combine all these smaller files into simple or fewer larger files, okay, depending on whatever your executor sizes are. So for example, you might fix your file size to be somewhere between 128 to 512 MB each file. Okay, so you are combining all the smaller files, making into one larger file, and then when you make the S3 request, you are going to make a lesser number of S3 requests. Therefore, you're improving the aggregate throughput. All right, fine. So that is all the strategies you have in place to improve your performance. And then you have what strategies can be employed to manage and reduce the cost of running AWS Glue job. So first off, we saw about the balancing between the cost and performance, and then in the above we learned just about improving the performance. And now in this we'll just see about how to cut down on the cost by using even while using Glue job. Okay, to manage and reduce AWS Glue costs, leverage auto scaling. You can try to use flex execution for your non-critical workloads, optimize your job performance through code and data optimization, utilize efficient worker types, employ data partitioning, disable development endpoints when not in use. Cost allocation tags can also help in tracking and analyze costs at a granular level. Okay. These are just one-worded answers that I have put at the top. But now we will discuss all these points in detail. Okay. First off, what you can do is you can try to leverage your AWS Glue features. So, what are the AWS Glue features that you can use to save your cost? You have auto scaling. So, when you enable the auto scaling, your resources will be dynamically provisioned, which means that you're not over provisioning or under provisioning, you're not compromising on your performance, and also you're not, compromising on your expenditure that is being spent for the particular job to be done. So, what I'm trying to say is that, let's say, okay, you have an 1 TB file and you need to process it. You might be needing 10 executors. So, if you already set your auto scaling the maximum threshold to be 10 and minimum to be 2, so now you need 10 and you can be processed. And later, let's say you just have like maybe 2 terabytes of data, and now maybe your system finds that it can be processed at ease uh, by like maybe you know 6 executor or 10 executor, whatever that is. So depending on your data sites and depending on the size of the executors, you can try to auto scale for a better performance, and you are also saving on the cost. Flex execution for jobs with less strict service level agreements, use flex execution to run jobs on spare capacity, significantly reducing cost. So whenever you have extra capacity to process your data, whenever you have an excess space to put in take in your data and then process it, then you can go for non-critical workloads to be processed in this setup. So this is nothing but a flex execution, right? And then choose the latest Glue version. So we already discussed about it, right? The more the latest Glue version, you'll be getting the better Spark version, better Python version, and on top you'll be getting additional features like, more features like what can I say, uh, improved cost, sorry, reduced cost, improved security, improved performance. So these are few things that you'll be getting on top. Optimize the job performance. Right sized DPUs determine the optimal number of DPUs for your job. Over provisioning lead to unused capacity and increased cost. So whatever the DPUs that you need, set it to the right amount. Okay, when you set it to the right amount, instead of over provisioning and just spending your money, you are just using the necessary DPU, and then you are processing the data with the reduced cost. Optimize data processing. Store data in S3 using partitioning, example by date, and query only the necessary partitions to reduce the amount of data scanned. So when you partition your data, what happens is that your data is partitioned based on the cardinality of a particular column that you have chosen for partition, and then it gets put into each of its executor. By doing this, instead of scanning the full table, instead of scanning all the file type, because you have partition, and when you provide this particular partition column value in your filter, you'll be saving the cost at the same time increasing performance. And then data compression. Compress data using formats like gzip, snappy to reduce data transfer and storage needs. So when you have when you're using the right data formats, what you can do is you can also use right data compression strategies as well. Therefore, you are saving on the cost, also you are having an improved performance as well. If you ask me, the best data format is using Parquet, and the best compression strategy would be Snappy over GSIP. All right, predicate pushdown. When you already use partition, okay, when you're already partitioning your data, now what you can do is you can use filter function, and by using your filter function, what you can do is you can try to push down your predicates, so you're filtering it earlier on. So for that you have PySpark's filter function, which will be filtering down based on the conditions that is in place. And instead of full table scan, the particular data only is selected and the rest is ignored, and therefore you're reducing the amount for your data to be processed. The logic is very simple. You're not going to process a particular data because you know that doesn't make sense because it is in a different partition. So you are using the rightful amount of resources for your right column of data. Okay. Optimize shuffles. Reduce the frequency and volume of data shuffles in your Spark jobs, which can be a costly operation. So when you try to reduce the frequency and the volume of data, okay, then you're saving on your performance. As I said earlier, when your data is in multiple executors, and when you are performing an aggregate function, or let's say you want to have a sum of every data or whatever that is, you're going to have lot of data shuffling. So the data from each of the executors gets moved onto each other, and therefore you'll be performing a white transformation. So white transformations are nothing but where a lot of data shuffling is involved. So by having, or by reducing the shuffle or optimizing your shuffle, you'll be reducing the frequency and the volume of data shuffles, and which would reflect in the cost. In this context, when you reduce, even the cost is reduced. And then off you have memory management. Monitor job logs. Regularly monitor job logs using CloudWatch to identify performance bottlenecks and errors that might be increasing job runtimes and costs. So you have set every strategies in place. You have all the strategies in place to save your cost, your performance, everything is fine. And now to monitor, what you can do is you can use CloudWatch. Even Glue has a console which you can try to monitor the status of a job, and what is the expense being put onto individual services. So there are these kind of features as well. Okay, so by using CloudWatch logs, you can try to understand where there is a performance bottleneck, and then you can work it out on the errors, and then you might have an increased runtime and reduced cost being spent. Set job timeouts. Define timeout thresholds for your jobs. Sorry. Define timeout thresholds for the jobs to prevent runaway processes caused by script or data issues from running indefinitely and incurring unexpected cost. So when you have timeout thresholds in place, you are preventing any runaway processes, which is nothing but sometimes your job might be running indefinitely, and you don't want that to be happening because See, worst come worst. Okay, only for like a larger data, you might be having a distributed and sorry, you might be having a lot of data to be processed, and there are chances that you might be having a runaway issues as well, which might cause an indefinite running. But under the hood, your data is not getting processed. So this is one common scenario in data engineering world, where your job will be running and you might be thinking is the data is getting processed and all these will be sorted out, but in reality it doesn't work that way. And sometimes it might even go like 3 hours, 4 hours, 5 hours, and you would be thinking something is happening, but what's actually happening is the resources are getting utilized, but the job is not getting processed, and it is a runaway error. Okay, so if you set timeouts depending on your data to be processed, you can save the cost. And then try to develop your logics and your code locally. Develop and test glue jobs or scripts locally rather than using glue development endpoints to avoid associated costs. So whenever you're using glue development endpoints, you are incurring cost for it. Okay, so what you can do is you can try to get a little bit of data to your local environment, and try to develop all your data in a local as well. So including your developing, your debugging, and all these can be done in the local environment, therefore saving on the cost visibility. Use cost allocation tags. So implementing user defined tags on your AWS resources to track and analyze cost by department, project, or application for better cost management. What if you need to track which project has utilized a certain number of resources? What if you need to track down which resource has actually taken a lot of cost? What if you need to keep a track of which project under whose whose lead the cost has been incurred a lot? So what you can do is you can have cost allocation tags in place by which you can track down the cost being spent. Okay, and therefore you can manage your better cost, you can better manage your cost being spent. All right, so that is all for today. I hope this session was very useful. If you like the video, do give a thumbs up and feel free to ask your questions in the comment section, and I'm more than happy to address them as well. And before we finish the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. And what we offer is we offer IT solutions, trainings, and placement support as well. So feel free to check out more about us Datavalley.ai, which is our website, and you'll be finding all information about the training modules, the placement assistance, and the IT solutions that we offer. And we have our headquarters in US, UK, and 4 data centers in Hyderabad as well. And soon we will be expanding our branches to Chennai, West Bengal, Delhi, Karnataka, to all the key IT hub centers. So we would expect you to provide your continued support as well. And I hope this session was very useful. And do subscribe to our channel if you haven't already. And don't miss out on the regular updates by clicking on the bell icon. So thank you all. And I wish you all good luck for your next data engineering interview. Bye bye. Take care. This is Franklin signing off. Goodbye.